linear and quadratic. We got to be able to understand they're going to test you upon this. So first off, you have your algebra, okay? Your algebra means that you have ax plus by is equal to c, ax squared plus bx plus c is equal to y. Make sense?
Yeah.
This, you have your slope intercept on this one, and on this one, what you have is you have your quadratic formula, okay? You also, on the right side, you also have your vertex form. Your vertex form is your h comma k shift, same with your slope intercept. So what you have is y is equal to mx plus b, right? On this side, what you have is x is equal to negative b plus or minus the root of b squared minus 4ac over 2a, right? Should be copying this stuff down. Your vertex form is if you had this, but we expanded it further, y minus k is equal to x minus h squared. We have a stretch factor of a. If you really want to get fancy, you can move that k over to the other side. This is your vertex form. Now, in terms of a graphical sense, we need to understand two quick things on this side is you just have slope. You can go positive or you can go negative, or if it's flat, it's a 0. If it's up and down, 1 over 0 is undefined. Okay? And then you have your b, your y-intercept. So you look at your graph, and if it goes across up here, b is a positive value. If it goes across right here, b is equal to 0. If it goes down here, b is a negative value. Okay?
Okay.
So for example, they can tell you and they say, okay, you've got a point of 0, negative 3, and you've got a slope of 2. What quadrant do you never hit?
Quadrant 2.
That makes sense? They like to ask you this kind of stuff. What is the value of b?
Negative 3.
Okay, pretty straightforward, okay? So if we have stuff and they ask which will it never touch, this will never touch the third quadrant, okay? So they'll ask you things like that. Just understand visually, you have your positive, your negative, your 0, and you have your positive, your negative, and your 0, okay? Same idea with this. If I were to just take this, we have a, if it's a positive, goes up. If it's a negative, goes down. We know that. Then c becomes the y-intercept. So you can go ahead and say, well, we got to talk a little bit further about this, but again, your standard one is just x squared. X squared has a root and a root both at 0 because it's like x times x or x minus 0 times x minus 0 is equal to y. And so whatever values that go into it to satisfy the 0 equation is where you end up crossing the axis, right? And so what does this mean? Well, we got to focus on up here. We got to focus on that quadratic formula. Quadratic formula has a lot of secrets within it. What I mean is that you have your vertex and then you have your discriminant. What do these two things do? Your vertex is the lowest or the highest point that causes both sides to be symmetrical. Does that make sense? You can fold it across that line. So let's start off with the easy one. X squared has a vertex at what? Well, if I look at it, ax squared plus bx plus c, a is a 1, b is a 0, c is a 0, right? So if I were to go put all that into here, you get 0, right, plus or minus. You get a minus 4, 0, right? So that becomes a 0. 0 plus 0 over 2, okay? Vertex and your axis of symmetry, okay? So this starts at 0, 0 and has a vertex at 0 because of that. Does that make sense?
Yeah.
Then what you have is, I teach you 3 main easy functions to worry about, okay? I'm actually going to do it this way. You start off in the very middle. There's 5 points we need to know, okay? You know this one. This one right here, I'm going to just say number 1 is y minus 0, because you're not going up or down anything. We're just going to call a's regular 1, so we're just going to be a positive going up. X minus 0, because do you see how this starts at 0, 0, right?
Yeah.
Squared, okay? So this axis of symmetry is at 0. Okay? This is the vertex. That's number 1. Then with number 2, I'm going to move it down to this. So now y, I can say, if I want to start y at negative 3, I got to do a y plus 3. That makes sense? So you can say minus, I don't say h squared technically. We'll say minus 3 gives you that, okay? That makes it a 0. It's equal to, still a positive number, x minus 0 squared. Actually, let's use a better number than 3. Let's use 4 just because that's going to give us that actual number we can use. Well, I'll see you next. Okay, axis of symmetry, still at 0. Does that make sense?
Yeah.
But how many roots does this have? This one is technically x squared minus 4. Do you see how that's x plus 2, x minus 2? It's a perfect square. That make sense?
Mm-hmm.
And so when we have this type of situation, this is where your discriminant, if I plug this into this, right? A is 1, B is 0, C is negative 4. Do you see that? So you got a negative, you got a plus 16 here, right? So plus or minus 4. Do you see that? When the value of your discriminant is a positive, that means your parabola touches the axis on 2 sets, 2 parts. That makes sense? So keep in mind, when each arm is a possible result, is a possible value. So when I go through the axis with a single line, that's the answer that we're looking for. That's the 0. When I go with my parabolas, if it doesn't touch, what is that? What answers do we get? If it doesn't touch, it's not an asymptote is where we don't have values. Okay? We can't use that value because it divides by 0. But what does it mean when I have a graph that's floating like this? What does that do? What does that mean about this?
The discriminant has a value
of? The discriminant has a value of what? There's 3 different things that can happen. We can have 2 answers. We can have 1 answer twice. Or we can have 0 answers. And the 0 answers are what we call imaginary. Okay? What we need to understand is that under the discriminant lies underneath a square root, right? What has to happen for a value under a square root for us to actually take a square root?
It has to be greater than 0.
It has to be greater than 0. If I take a square root of 0, I don't add or subtract anything. If I take a negative number, I can't evaluate it. It becomes an imaginary value, right?
Yeah.
Your discriminant was positive. It gave you 2 answers. Your discriminant was 0. Your vertex is the answer. You couldn't evaluate your discriminant, and it's imaginary, therefore it floats off of the graph. It doesn't touch the x-axis. Does this make sense?
Yeah.
Did they teach you this in school?
No.
Okay. This is a very important concept to understand. Your discriminant is based upon the fact that with square roots, we can only take certain numbers. If we put in a 0, then our axis lies there, okay? What I want to do right now is, because I understand this concept, I can see it's not clear yet for you, okay? So what I want to do here is you're going to take a blank page, and this is how you're going to evaluate them, all right? What I want to start off with is you always start off with this guy, okay? He's normal. What we want to understand is with this, we have how many roots?
There's
Regular x squared. How many roots do we have?
roots are where x equals 0. Right? Only 1.
Yeah. X is equal to 0 is a root. And technically, because it's, right? It's a double root. And so that's right here. Leg 1 gives you that answer. Leg 2 gives you that answer. That make sense?
Yeah.
Now, what I want you to do next is underneath him, draw him in the middle. Because we're going to do this too. We're going to go up and down 1. Now, be careful with this one. This is supposed to be able to factor, right? Whereas this one cannot factor. What I want to do next with both of these is we're going to quadratic equation both of them. Give me your quadratic equation and give me your value for it.
Okay.